Okay, this is the last analytical geometry question in our paper 2. And here, let's just take a look. It's important, really important, to read all this carefully and make sure you got it right, because if you don't, you need the information up here before you start. In the sketch, there's this A, B, C, D. It's a rectangle. And that's real important because you know rectangles have 90 degrees in the so you know all those angles are 90. You know those two sides equal those two sides. Maybe that's useful, but that first thing's important. They give the points: -6 and 6, -7 and 4, 0 and 3. This is the y-axis. That's like a little corner there, a y-intercept of that line there. -1 to the left, and we don't know how far up. We call it t. There's an angle right here, alpha, between this horizontal line here. That's really important. You see the line BK and the line MO, I think they tell you they're parallel. BK is parallel to this x-axis, so it's pointing exactly straight across here. Okay, that's real important. The angle of inclination is alpha here. So, we've got an angle, we can get a gradient. That's the idea. Or if you've got a gradient, you can get an angle. But both ways. That's real important. Okay, let's just try the first question. The first question is, state the coordinates of K. Well, there's K. It's at the same level as here, and the x-coordinate is 0. So it's 0 and K. That wasn't too hard. What's the size of alpha? Well, I don't know, but I can get the gradient here. And if I get the gradient, if I go shift tan of the gradient, it'll tell me what the angle is of this angle of inclination. That's what the tangent of the angle is equal to the gradient. That's the big idea. See, there's A, B. Well, there you've got A and B. Just find the gradient. 6 minus 4 over -6 plus 7. That looks like it's 2 over 1. That's 2. Shift tan of 2, my calculator tells me that alpha is 63,43 degrees, and that's your answer for alpha. And now the next question is kind of tricky. Well, it's not so tricky, really, because it says, hence, determine the size of angle beta here. Well, I got this angle down here. How am I supposed to get this angle? Well, they told us that this BK is parallel, so it's a parallel. BK is parallel to MO. This, from grade 8, we should remember that the angles inside parallel lines add up to 180. And we know that that's 90 degrees because it's a rectangle. Well, we've got that angle's 90. We've got that angle there is 63.43. Then if we go 180 minus those 90 plus 64.43, we get 26.57. The reason is co-interior angles, because BK is parallel to MO. I think I'm just going to leave it there. We'll go 3.1 to 3.3. We'll do the rest a little bit later in the next video.